Hey listener, welcome back to another video on this channel, and today we will do something different. We will talk about cats and dogs and stuff like this, because we will talk about object-oriented programming. And this is a topic that I never touched on YouTube. It's a little bit advanced, but if you break it down, it's not really complex. And yeah, you requested more stuff like this, so we will do something like this. So object-oriented programming is just the approach to make programming or the programming language more similar to the real world. So it is easy to understand as a human programmer and to put data into a logical structure. So if we talk about object-oriented programming, we mainly talk about data structures and structuring the source code. So let's have a look at this. I will go to the MetaQuotes language editor right away. So go to Tools, MetaQuotes language editor to open the language editor where you can write new programs. And we will create a new expert advisor. Go to the upper left corner, expert advisor, click on next, object-oriented programming demo. You can choose any name. This is I just choose this to show you one or two things. So then click on next, next, and finish. So now we have this program, and let me quickly delete the unnecessary lines here. I will not explain like every single step here, like none of these absolutely basic steps, because if you never had a look at programming in MetaTrader 5, this is probably not the first video that you should watch. There are better tutorials suitable for absolute beginners on this channel, so you should go watch them, and this is a little bit more advanced. So the easiest way to explain object-oriented programming is by having a look at an example. So when we talk about object-oriented programming, we talk about classes and objects most of the time. A class is a template pretty much for something that can exist multiple times. So for example, we could have the class CDoc, and the class names usually start with a capital letter C and then the name of the class. But I mean, it would also work if I write it like this. This is not a critical error. It is just a coding convention that you start class names with a C. So this CDoc class can be created like this. This would be enough to create a class CDoc. And we use this class because we can have multiple dogs. I mean, you as a person could go to a dog shelter and adopt one or two dogs. So you could go ahead, and now since we defined this class, this is a class definition. So now the program knows that something like a CDoc class exists. So now we can go ahead and use this CDoc class to create multiple dogs. You can have dog 1. And if I compile this, you can see this works just fine. And we have dog 2, like this. So we can create as many dogs as we want now. And you might ask yourself, why are we doing this? We do this because all of these dogs can have a specific height, for example. So we could have a member variable here, and all the variables and functions are member variables and functions of this CDoc class. So we could go ahead and create a variable which is named height, like this. So when you have a look at classes, you will often see something like this, like small letter m and then this underscore and then height. This is again just a coding convention. A lot of programmers use this because this means it is a member variable, but it doesn't really change the outcome of the program. So doing this is pretty much exactly the same for the PC as doing this. And you can do whatever you want as long as you understand your program. But if you want to be like really strict and stick to the coding conventions that many programmers use, you can do it like this. I often just write height without using the m underscore, because usually MetaTrader 4 or 5 programs are so small that it's really, really easy to understand them, especially if you are the only one writing the program and nobody else helps you writing them. But yeah, you can also do it like this. And then the docs can also have a color like this, for example. And now you probably start to realize the benefit of using a class definition like this, because since we defined this class, so what we're doing here is basically we say to the computer or to the program or however you want to call it, that we will have some kind of data structure that looks like this. It is the class cdoc, and every single doc has a height and a color. And this is why all of our 3 docs here now have the height and color parameter pretty much, because it is a member variable of this cdoc class. And here we use the cdoc class to create 3 so-called object variables or instances of the cdoc class. So what we can do now is, or what we could do now is change the height of the docs. But this doesn't really work right away, because if I try to change the height of a doc like this, it will not work. And this is because the member variables are private by default. So private variables can only be used inside of the class itself. So if I would have a function here like void print height, something like this, and you can create functions inside of the body of a class just like this. And then every doc will have this function. And then I could say something like the height is, and then I print it. Height, like this. And you can see this does not throw an error. The only error is from here. But if I compile it like this, this does not throw an error, because mHeight can be used inside of the cdoc function, because this is private. These are private variables and they are private inside of the function. If I want to use these functions outside of the class, I would have to make it public like this. And this is like the easiest way to just enable or just make all your member variables and member functions public for everyone, to just write public at the very top, and then everything is public. You could go ahead and create multiple sections like this. Now this would be public, this would be private, but yeah, we will just go with public for everything because it's the easiest right now. So now I can go ahead and change the height for the docs. So I could say that the first doc is 12 meters big, the second one is a little bit bigger, it's a big doc, 23 meters, and the third one, oh wait, I have to choose the docs like this, 1, 2, 3. The third one is a little bit smaller. It is just 2 meters or 3 meters big. So if I compile it, you can see now we do not get an error anymore, because now all of these member variables are public. And yeah, this worked just fine. Now we have 3 different docs, and they all have a different height. So we could say something like print starts or something, height is blah, and the color is mcolor. So we just print everything that is inside of the docs, or we print all the docs parameters here. And now I could go ahead and say doc1 dot print starts, doc2 dot print starts, doc3 print starts, like this. Or maybe, yeah, we will just do it like this. And if I compile this now, we can now run the program. And yeah, this is just like really normal. You go to the MetaTrader, you find the program. It should be object-oriented programming demo. You apply it to a chart, bloop. And in the expert journal, we should see the height is 12, 23, and 3. And the color is always color black because we didn't change it yet. And this is because we changed all of these parameters. If we would change this and move it up here, it would give a different result. So let me clear this. And if I compile this again, this would now say the height is 0 for everyone, for every doc, because this is the default value and we didn't change it yet. But if I print it here, or if I call the function here, you can see that, we updated the individual height for every single doc, for every single object variable. So every doc now has a different height. And now you should start to realize the power of this object-oriented programming. Like this CDoc class is now really a template for every single doc that you might see in the world or in your program or whatever. And if I would not use this CDoc class, if I would not use object-oriented programming, and if I still wanted to have 3 heights for docs and 3 colors for docs, I would have to do something like this. Doc1 height, Doc2 height, and Doc3 height, and color, Doc1 color, blah, 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 like this. So you can see this is really messy and it's not really structured. And if I would have 100 docs, it would be like super confusing. But if I choose to apply or to use the object-oriented way of creating a template for the doc, you can see this is much more intuitive. So a programmer will understand this easily, because this is something that we know from the real world. Like we have docs, and we know every doc has a height and a color. So we can simply create this kind of template or class structure to create something that applies to every single doc. So now, we can do something like this. And we could also say this doc can bark. And then we can say we have this other function here, and we say the height meter tall dog just barked. You better run. Something like this. And now you can see I just have multiple functions inside of my CDoc class, because docs can do multiple things. I mean, they can perform multiple actions. And I could say something like doc2 2.bark. And this little dot here that I write after I call or after I write the name of the object variable, this is just I think it's just called point operator, and you use it to access the member variables, so variables and functions if they are public of a class. And if I compile it like this, you can see that I get the output that I got before, but now the 23-meter tall dog just barked at you, so you better run. So you can see this is how you can use object-oriented programming. Also, there is more to object-oriented programming. For example, you could say, you have multiple docs and stuff, but what happens if you want to be more specific? There are not only docs in the world, but there are different kind of docs. So we can have a look as dog species. So you can see there is the German Schäferhund, there's the English Bulldog, there's the Labrador. I don't know if I think these are the German names. But how many species? You can see there are a lot of different dog breeds. There's the Labrador, and we can just use like Labrador and Terrier, something like this. So you could say that, now we have this dog class, but we want to have a even more specific class, like class C Labrador like this. And then we have another class, and you can create as many classes as you want. And now, of course, every single Labrador, since it is a dog, it has a height and a color. So we could go ahead and create these variables here, but this does not really make sense, because we already have this CDoc class definition, and we know that every Labrador is a dog. Not every dog is a Labrador, but every Labrador is a dog. So what we can do is we can say we want this class to inherit from this class, because we know that every Labrador is a dog. So since every dog has a height and a color, a Labrador should also have this, right? So what we can do is we can say, we write the class definition C Labrador, then we write colon, and then we write public C dog. This means that we want to inherit publicly from the C dog class. So we now have access to all the variables that are inside of the CDoc class, because we are saying that since every Labrador is a doc, it should have the same public class members as a doc. And what we can do now is we can say that or maybe let me create another doc breed here. We can say class C Labrador, C Terrier, because this is another doc breed, which is of course also a doc. So what we have here now is we have 2 more classes. So in total we have 3 classes. In this case, this is a super class because it is above the C Labrador and C Terrier class. And what we can do now is we could use the CDoc class to create docs. This, of course, still works like this. But we can also use the C Labrador class to create a Labrador. And we can use the C Terrier class to create a Terrier. And I mean, I don't have to write Labrador and Terrier. I could write Bob and Bernd. Doesn't really matter what you name them. And you can see now in the onInit, I can say doc1 m height is equal to 1, doc1 bark. And the cool thing is Bob can also have a height, and Bob can also bark. And Bernd can also have a height and a color, of course. And Bernd can also print stats, because since the C Labrador class and the C Terrier class, they inherit from the CDoc class, and this colon public CDoc, this is just a syntax pretty much. So there's no like crazy meaning behind this. This is just a syntax that is defined by the creators of the programming language. So you just do it like this in this programming language and in other programming languages like C++, I guess. So since we inherit, every Labrador and every Terrier has access to these member variables, or to these variables and functions. So you can see here, if I run the program, everything just works. So I mean, I could also go ahead and say every doc has a name like this. And then we can use the name here, which is maybe a little bit better. It's a little bit cooler to use the name and not just say something else. So what I can do here is I can say doc1 name is it's actually doc1, but for Bob, who has a actual name, we can use this name, and Bernd also has a name, of course. So we can use this. So if I compile this, you can see now the code is really cool, because it says Bob is 3 meters tall and Bernd is 5 meters tall and the color is black and stuff. So you can see this is now really showing the power of object-oriented programming. And you might assume that I mean, a Labrador can still have different attributes than a Terrier has. For example, a Labrador, maybe the Labrador is able to bring stuff, and the Terrier is not able to do so. Bring toy, or return toy or something. Return toy. So we can say print name returns the toy, like this. And since this function is now only part of the C Labrador class, the Labrador Bob can do it. Return toy. Oh, of course, only if you make this public, because this is the same principle. By default, everything is private in a class, but if we write public, it now works. And the C Terrier, it doesn't have this return toy function, so it cannot return a toy. And this is why different subclasses can do different things. And this is why you need inheritance, because often you have a superclass that just builds like the general structure of something, and then you have subclasses which can be a little bit different, and this is why you need these subclasses. And maybe a terrier is able to fight intruder into your house. So you can say something like print name fights the robber. Something like this. And this is something only a terrier can do. And a Labrador is not able, because a Labrador maybe would run away or something. So you can see this is, oh, is it public? No, it's not. Public fight intruder. Something like this. So you can see now, if I compile this, every dog can perform different actions. Like Bob can return toys, Bernd can fight the robber. And since this is not something only Bernd and Bob can do, but it's specific to the class pretty much, we could have another terrier, which is Bertha. And Bertha, we should give her the name. Name is Bertha, like this. And Bertha can also fight intruder, like this. So you can see, if I run it again, you can see Bertha fights the robber. Because Bertha is also a terrier, of course. So you can see this is why you can use object-oriented programming to add logical structure to your source code. And you use object-oriented programming, or you can create classes if you have a specific data set that you want to use multiple times, or if you just want to have a nice and easy class that you can then include into different projects, because you know that you have some like basic functions or so that you want to use multiple times, and then you can do it like this. So this is a little introduction into like object-oriented programming. There's more stuff when it comes to object-oriented programming. You can talk about these, wait, what's the English name? Access specifiers. More, there's private, public, and protected, and everything has a different meaning. Also, you can have constructors and destructors for your classes that are called if the class is, or if an object is created or destroyed. There is more when it comes to object-oriented programming, but this is just like a basic introduction. So you understand, if you see a class or a object, what it means. It just means that there is a class definition somewhere, and you can have a look at this class definition to see how this object, or why this object can do what it can, because you can have a look at the class. And if you want to learn more, check out the link in the video description. You will find a link to the MetaTrader 5 masterclass, where I explain all the necessary concepts or all that you need to know about object-oriented programming, so you're able to use it for trading. And this is a good point, because right now we only worked with docs, so this of course doesn't really have a big impact on trading, because you won't find a doc running through the chart, but you can of course apply this to actual trading scenarios. So this was just to demonstrate how object-oriented programming works, but you could, for example, write a program that creates multiple ranges in the chart, and then you would have something like M range high, M range low, and double M range size, something like this. And this is something that I used, for example, if I created range breakout EAs and stuff. And so now I could go ahead and create multiple ranges here, range 1 and range 2, and so on and so on. And every single range now has a range high, a range low, and a range size and stuff. And you can also create ranges in the onTick function. And this works. You can create as many ranges as you want. And you could also go ahead and store them in an array. And this is all stuff that I teach in the MetaTrader masterclass. So if you're interested, check out the course. And yeah, I hope that you like this little insight in object-oriented programming. There's one last thing that I want to show you, because we talked about this on the channel so often, and it is the C trade class. And by now you should understand that the C in front of the CTrade class, like this is what we included so often when we open positions. It is this trade/trade.mqh, which enables us to use the CTrade class to create a object like this. And I did this in so many YouTube tutorials. I never really explained it, but now I can explain it because this CTrade class is of course just a class. So we can have a look at this class now. So if you go to the navigator, go to include trade, and then open the trade.mqh file, you will find the CTrade class definition. And as you can see here, this looks exactly like the CDoc class. We write class, CTrade, : it inherits from the CObject class. So you could have a look at this. Then you can see there are some access specifiers specified like protected, public. This is something we know. And you can see there are a lot of member variables. Here you can see the syntax used like m_. And then this is constructor and destructor, which I didn't cover in this video. And you can see there are just a lot of functions. And since we create the trade object variable in many of our programs, we can use this trade object variable to just run the functions that are defined here. So a function that we used really often is the buy or the sell function. So if we have a look at this, if I move my cursor here and then press Alt and G, I can jump to the function here, and you can see this function is defined here, and it calls another function, which is this one, and you can see this function just sends an order. So what this whole CTrade class does is it simplifies working with position openings, position closings, position modification and stuff, because all the work is structured in the CTrade class in a logical way that makes it really easy for us to use if we just create a object variable of the type CTrade. So you can see this is like the power of object-oriented programming, and since we have this class definition here for the CTrade class, this is created once. I mean, this is by default part of the mql5 framework, so we do not have to create this in every single program, and this is like the power of object-oriented programming. So yeah, I know this can be a little bit confusing if you never worked with object-oriented programming before, but I was hoping to explain it like in a really simple way, break down the concept, like using this dogs and Labradors and Terriers and stuff to really explain like why we do it, how we do it, and what the power of object-oriented programming is. So yeah, let me know what you think in the comment section below. Was I able to like transport the message a bit? Was I able to explain it a bit? And yeah, if you learned something in this video, make sure to leave a like and maybe also watch 1 or 2 more programming tutorials on the channel. I really appreciate the support on the channel as always, and I'm glad that many of you were able to learn something here. So thanks for watching, have a great time and good trades. See you next time, bye bye.